Alright everybody, Mr. Gazdonian here, Applied Physics number 14. Here we go. Just to remind people of what we did here in class. So, you want to find the x component and the y component, round to the tenths. So in this case, what you're going to do, this is going to be the hypotenuse. This right here is going to represent the vector in this direction, so this is going to be our y component. And then this right here, the vector here, this will be the x component right here. So, to do that, you need a calculator for sure, the sine and cosine functions, and here's my version of the sheet that we have that shows it, okay? I had to redraw it. This is your angle, this is the opposite side, the adjacent hypotenuse, okay? So, sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, so we have the hypotenuse and we're going to have the angle. So for this case, what we want here is the y. We want this is the opposite side, so we want to do sine theta. So what I have here is so to find y, it is going to be sine of 60 equals opposite, that's what we're looking for, opposite over 58. And so we have to get it to get opposite side by itself, you multiply both sides by 58 newtons, they cancel out, multiply that by 58 newtons right there. Sine is 60. Now you'll see this calculator I have is a bit older in that, so I have to do it this way. 60 sine gives me the number, I multiply that by 58, and I get rounded to 50.2. So it's 50.2 newtons. I'm sorry. That was all. This is all the y component work. So sorry about that. 50.2 newtons. That's the y component. The x component is going to be the cosine adjacent over hypotenuse. So, and I think you get the sense from looking at the x component is going to be less than y just from visually looking at it. So what you're going to have is I'll do the math right here. You're going to have cosine 60 degrees equals adjacent over hypotenuse, which is 58 newtons. So again, multiply them both here, they cancel each other out. 58 newtons, multiply. So again, most calculators are cosine, then you do the number. This one is a little older, you this time cosine of that, it was just 0.5 times 58, 29 even. 29 round to tenths, it's even, so it would be 29.0 newtons. And you know, this makes sense for us in that, just looking at this, it's definitely more, the y component should be larger than the x component. So, okay? Second one, number 2. Here, let's do a nice cleaner copy of number 2 right here. So this case, I'm going to, the arrow goes a different way, that shouldn't matter. This right here, if that's a right angle, this is the y component, and then the x component. And if you remember doing adding vectors in class, it's as if you had this and this head to tail. This is the resultant, so that's 95. So to find, let's do x first properly, as I wanted to before. So therefore x is going to be, and feel free to go back to this, x is going to be right here. It's the adjacent, so we're going to use cosine, and the angle is 35 degrees. So cosine 35 degrees equals adjacent, which is x right here. Adjacent over hypotenuse. Oh, sorry, and we know the hypotenuse to be that's 95 newtons. Okay. So multiply this side, because it's on the bottom of this, multiply this by 95. Well, you do one side, you do the other. 95 newtons here. And then cosine of 35. 35 cosine times 95 newtons is 77.8. 77.8 newtons. Yeah, and I guess visually it does looks reasonable. Let's see, y is probably going to be a little bit less. Y, going back to this, is going, if that's the angle, we want the opposite. That's what y is, so we want to use sine opposite over hypotenuse. We'll do it like this. Sine 35 degrees equals opposite over hypotenuse, which is 95. And newtons, 95 newtons here, cancel each other out. 95 newtons times sine 35. 35 sine times 95. 54 point, and that's going to round to a 5. The 8 makes it a 5. 54.5. 54.5 newtons. Okay? So, I think this all rings a bell from what we did in class. Go on to the back. Do number 3, number 4, and number 5 on the back. Good luck. Mr. Gazda, signing off.